Hello and welcome back. And in today's lecture, we are going to see that how under the hood this TF IDF vectorizer work. So we have understood about the TF IDF. TF means term frequency, IDF means inverse document frequency. For more details, you can refer to the previous videos. Those videos are really important because the program or the machine learning model that I have created here, you need to understand it in full. So I'm creating the models and then I'm explaining it line by line, and whatever mathematics is needed there, that I'm going to explain to you. You don't need to understand the mathematics from the beginning itself. You just need to understand the model and then whatever concepts have been used to prepare that model. That way you can understand your requirements of the mathematics, and you can understand those concepts used in the mathematics, and then you can build your knowledge, right? So this will be the fast track method as per my understanding for you to understand the machine learning and how to prepare your machine learning models. So in the TF IDF vectorizer, we have understood like what is TF, what is IDF, and apart from TF IDF, there is one more count vectorizer. This is really simple, and we will understand this one as well in the coming videos. But in today's video, we are going to see that how TF IDF vectorizer works under the hood. Okay. And then we will see the count vectorizer, that how it works under the hood, how it arranges the words in the document or the terms in the document, and how it assigns the significance number to those words or to those terms. Because the significance numbers assigned to those words or to the terms, it decides that about what this particular document is talking about. Okay, so to decide like what is the central theme of the document, or what about this document is talking about, what are the sentiments, for that we need to give the particular assignation, the IDF or the term frequency multiplied by the IDF, or you can say the weightage to each of the words. The weightage assigned to each of the word, which is basically the term frequency into the inverse document frequency, that weightage decides that how significant is the word or is the term to decide the sentiment or to decide the central theme of the document. Okay, so before that, I would like to show you one more thing in the code. That in the code you might have seen that there are both the two models, like TF IDF vectorizer method and the count vectorizer methods, both we have used. And finally, we have finally we have fit the model with respect to the count vectorizer. So ultimately, whatever tool you are using, if you are taking this particular code that I have provided to you under the comment section in the first video itself, then it means that you are using the count vectorizer. You are not using the TF IDF vectorizer. If you want to use the TF IDF vectorizer here, rather than x train count y train, you can give like x train TF IDF and then y train, right? So y train is already provided here. You can see that y train you have already split it, so that you can provide. So if you want to use this model, this TF IDF vectorizer model, then you can change this. Rather than x train count, you can provide this x train TF IDF, this variable at the line number 43 that you are able to see. If you provide this, then also you can run your program and you can see whether it is giving you the correct result or not. We have used a very limited set of data, but the thing is that if you see in terms of a vast data, then in that case, if you are working on the sentiment analyzer, then in that case this TF IDF vectorizer method is really useful because it assigns the significance number, right? But since you have not understood this, you have not read this count vectorizer, so until I tell this to you what is count vectorizer, you will not be able to understand that which one is better for the sentiment analysis and why, right? So as of now, focus on the TF IDF vectorizer, and I must say that if you have copied my code, then you can simply put the x train TF IDF here, and then you can see what is the output. Is the output same? I think the output will be same, and I have run it. It is same because we have a very less amount of data, right? So if you test it, then you will, after testing it, you won't be able to understand the difference between the two. Which one is better, you won't be able to understand. But in terms of vast data, when you use the vast amount of data, then in that case, you will be clearly able to see that this particular TF IDF vectorizer is really useful compared to this count vectorizer. But as of now, since you have not understood this count vectorizer, So just you can keep this in mind that I have told this to you. But in coming videos, we will understand this count vectorizer as well, and you will be, you know, clearly able to understand that why I told you that this count vectorizer is really useful. Sorry, this TF IDF vectorizer is really useful compared to this one, count vectorizer. So now let us see that how under the hood things are working, how the TF IDF vectorizer works. So you can see in the program that here we have done this thing, vectorizer.fit transform, right? What does this fit transform method do, right? Let us see. This fit transform method, it prepares the final matrix to, you know, predict the output for a given input, right? As of now, it is using the training data, but in the real time, you will provide some real data, and on that real data, based on the training done, it will provide you the results. Okay, so fit transform involves two steps. One is fit, and the other one is transformation. So for the first step, like fitting, it reads the training data to create a vocabulary of unique words. So basically, when it reads the data, it first of all creates the vocabulary of unique words. We will see like how it is doing it. And then for each of the unique words, it calculates the IDF, which is the inverse document frequency. In the previous video, you can understand that what is the IDF, right? IDF is inverse document frequency. I mean, if a word appears over the document's large number of time, then its inverse document frequency will be smaller and it will be really insignificant, right? So since since we will be working on the large amount of data, so when you are working on the large amount of data, to normalize the values, we use the log, right? So we have to use the log when you have the large amount of data. So n means the number of documents. You can see the number of documents, total number of documents. Suppose there are 300 documents, right? And df is the number of documents containing a specific word. So for each of the word, this inverse document frequency is calculated. Suppose there are 300 documents, for example, and there is a word, say dog, right? So this dog will be found that in how many documents this dog word appears. So this n by df, which means the number of documents, 300 by df, which means the document frequency. Suppose dog appears 150 times. So this 150 will divide this total number of documents, which means 300. So n has become 300 here. And the df, document frequency, means the number of documents where this dog word appears is 150. So in the 150 documents, this is appearing. So you will divide n by 150, which means the result will be 2. So you will find out the log of 2, right, for the word dog. So that will be the significant, significance identifier for your word dog. And based on that, you will decide that what is the, significance of that particular word for a particular document. Here we have taken this all number of documents, but when you are talking about a term in a document, then in that document itself, you will find out the term frequency. Like dog can be, dog could be spread across 300, out of 300, 150 documents, dog word can be there, right? So now, when you find out the IDF, which is the inverse document frequency, after calculating that, you can try to find out this particular word dog in a specific document. Out of 300 documents, you are talking about one document where this word dog you are looking for. So you will see that how many times that dog word appears in that particular document, right? That will be known as the term frequency. That term frequency will be multiplied by the IDF. Don't worry if you are not able to understand, then we are going to see this with the help of an example, right? So we are going to do that. So let's not waste our time here. So I will tell you with the help of an example. After identifying the IDF, you need to go for the transformation. At the time of transformation, you tokenize the text into words. Whatever text you have found, you have to, whatever text you have given, that text you will use as a reference and for the training, and then you will tokenize that text into different terms or into the different words. For each of the word, you will calculate the term frequency, right? Now the term frequency is defined over a particular document, one document. right? When we were talking about the document frequency and invoice document frequency on the top, then we were discussing about the entire set of documents, right? Now we are talking about a particular word in a single document, right? That is known as the term frequency. So number of times a word or term appears into a document, that is known as term frequency. Now you have found out on the top, you have found out the idea, which is the inverse document frequency. Now you will multiply this IDF into the term frequency. Suppose for the dog word you are looking into a single document. In that single document, if the dog word appears thrice, then you will multiply 3 into the IDF, which is the inverse document frequency, and that will be the TF IDF score, which is the significance number of that particular word or the term into that document. Okay. The resultant TF IDF score arranged in a matrix. Whatever TF IDF scores you are getting, that you will arrange into a matrix. In that matrix, the rows will be there, the columns will be there. The rows will be representing the documents. A single document, a single row will represent single document, and single column will represent a single word, right? And then whatever values have been assigned, they are known as a TF IDF score or the significance score. Now, this was the entire theory. Now you need to understand with the help of an example that how you can calculate it. So there is an example. For the simplicity, we have taken only two documents, document 1 and document 2. In case of document 1, the words have been written like the quick brown fox. There are 4 words, the quick brown fox. In the document 2, there are 3 words, the lazy dog, right? Now, first of all, you need to create the vocabulary. So, array of vocabulary. So, the quick brown fox and then the lazy and the dog. We have not taken this the from the document 2 because we have already taken the word the in the beginning. So you have to take the unique words from all the set of documents, right? From the set of documents, you have to find out the unique words. You don't have to repeat any word. Basically, you have to create a set of words or set of tokens, because set is a unique collection of the objects, right? Similarly, here the vocabulary will be the unique collection of all the terms or all the words here from the document 1 and the document 2. So the quick brown fox, lazy dog, these are the 6 words in both these documents. Now, I hope you might be able to get the clear idea, like how it is done practically. Before this, a few of the things might not have been clear to you, but still, because this is an example, this will make you clear. Now, what was the second step in the IDF? In the TF, in the case of fit. In the case of fit, the second step was calculating the IDF. So we have to calculate the IDF for the word the, right? So for if you see the word the, then how many documents are there? 2 documents are there, and the word has come. In the documents, how many documents this the word has come? In the 2 documents. So if you take log 2 by 2, it becomes 0, right? So significance will be 0. The TF IDF score will be 0. Now we come to quick. So in case of quick, how many documents are there? N is equal to 2, right? And in how many documents it came? What is the document frequency? How many documents this quick word has came? It only came in one document, right? So that is why you will divide it by 1. So log 2 by 1, which means log 2, and the value of log 2 is 0.693. I hope you might be remembering your old college days where you might have learned these things like logarithms, and this log 2 and log 3 values were very famous, right? So this log 2 value 0.693 has been assigned to this. Now you can understand what will be the what will be the IDF for brown, because brown also exists in only one document, right? So the DF, which means the document frequency, is 1, and the number of documents are 1 and 2. 2 documents are there, and it appears only one among these two documents, right? In only one document. So the IDF will be 0.693. Similarly for fox, you can see that it only appears in one document. Similarly for lazy, you can see that it only appears in one document. Dog also appears only in one document. So 0.693 will be the TF IDF, the IDF score assigned to each of these words, for each of these words, right? So 0.693 is there. Now, what we have to do, we have to do the transformation. When we have to do the transformation, then we have again taken the document one. But in this case, in the document one, I have not taken only 1, 2, 3, 4 words. You can see there are 1, 2, 3, 4, 5, 6 words. Why? Why this is a array of 6? Because we have to calculate with respect to this one, right? The quick brown fox, lazy dog. Now, if you see, if D exists in the doc one, yes, D exists in the doc one, and its score is 0, right? For the document two, the score for the quick, for the document one, for the quick, what is the score? IDF score 0.693. Now the quick is in the document one. You need to only see that where the document, what are the words which are in the document one, right? So the quick is in the document one, and we are talking about document one. So since the quick is in the document one, and it has term frequency 1, because in this particular document it came only once. This quick has came only once, so the term frequency is only 1. Remember that term frequency is defined as the number of times a particular word appears in a single document, right? So the term frequency of quick will be 1. Now this 1 has been multiplied by this DF, which is the IDF, which is the 0.693. So this will be 0.693. Again for brown, it will be 693. Now for the fox, you need to see here, fox 0.693. Now lazy, 0, because there is no lazy in the first document. Dog, there is no dog in the first document. So 0. So now I hope you might have understood that how these are calculated under the hood, right? So this is the mathematics involved. And now for this document 2, I hope you might be able to clearly understand that how we can assign it. So the quick brown fox, all these words are not available in document 2. So for the document 2, for the it will be 0, for quick will be 0, for brown it will be 0, and for the fox it will be 0. But for the lazy and dog, you can see for the lazy and dog, it will again be 0.693 and 693. Right? So for the document 1 and document 2, we have decided the words which are significant. So if you have to find out the sentiment, or if you have to find out for what these documents are talking about, or for what this particular one document is talking about, you can decide, you can predict based on the scores assigned, the TF IDF scores assigned to this, the significance values, or you can say the weightage assigned to each of the word. So whatever weightage has been assigned to the different words, and whatever term or word has the highest significance number, that will decide the sentiment, or you can say the central theme of the document. So this is how you decide it. So with this particular explanation, this particular video comes to an end. We will meet in the next video. Till then, have a nice day, and bye bye, and please like, share and subscribe. Thank you. Have a nice day.